Good morning, my lovely kiddos and my future mathematicians. Today we're going to be on page 41 and 42, and we are going to be introducing literal equations. So literal equations are going to help us answer the question, can we do math without numbers? And that answer, spoiler alert, is yes, we can through these literal equations. So first of all, let's define what a literal equation is. So a literal equation is an equation with more than one variable and it can have numbers, but there's no guarantee that it will have numbers. Okay. And then second thing I want to go ahead and define is our like terms. We have defined this in our notebook before, but we're going to redefine like terms because this is really going to help us today. Remember that like terms are terms that have one, the same exponent. They have to have the same power. And two, they have to have the same variable or that same letter. All right, so let's go ahead and look at a traditional equation versus a literal equation. Just a one step real quick here. So our traditional equation has numbers, has things that look familiar, like the things that we have been working on. Such as x plus 6 equals 12. And we know exactly how to solve this. First step is to draw that line down the center of the equal sign, and then to get that x, that variable, by itself, we are going to look at what we are doing to that x. In this case, we are adding 6. To undo that addition of 6, we are going to subtract 6 once on each side, bring down that x because we did not add or subtract anything to that. Add 6 minus 6, those are going to cancel because they go to 0. And then 12 minus 6 gives us 6, very simply. However, like mentioned in the definition, literal equations doesn't always have numbers. So let's take a peek at what that looks like. I'm going to do the exact same equation, except instead of numbers, I'm going to write more variables. So we're going to have x plus a is equal to d, and then I have a little semicolon here, and it's going to tell us that we are solving for x. But we're going to do the exact same steps that we did in the traditional equation. We want to solve for x, so I'm going to circle x so we don't lose it. Hey, we're trying to solve this right here. And then we look, what are we doing to that x? And again, we are adding something to it, this case an a instead of a 6. But our process is going to be the exact same. To undo that addition, we are going to subtract that a once on each side. Once again, bring down that x because we did not add or subtract anything to it. Once again, positive and negative a cancel because they go to 0. But this is going to look weird. Because d and a are different variables, they are not like terms. So we cannot combine them into some other letter. D minus a does not give us b or p or some other variable. Since they are not like terms, we're simply just going to write them right next to each other. And that gives us a very important note that we're going to make a star for right here. And that is going to be our answers are not pretty. They're going to look weird and odd and just gross. Our answers are not going to be pretty. Okay, let's scooch this up and let's do a couple examples here. Okay. So we have 9 examples total today. Our first one, we have u equals x minus k, semicolon, 4x. Okay, so the first thing we always do that we have been doing since we introduced equations is that we are going to draw that line down our equal sign. And then now what we're going to do is we are going to circle the variable we want to solve for, in this case, an x. So we look, what are we doing to that x? In this case, we are subtracting k from it. So to undo that subtraction of k, we are going to add k once on each side of the equal sign. U and k are not like terms because they are different variables. They are not the same variable. So we are simply going to write them right next to each other. Bring down our x because we did not add or subtract anything from that. And just like with numbers, negative k plus k, those are going to cancel because they go to 0. And we know when we are done, when our variable that we were trying to solve for is alone on one side of the equal sign. So since that x is alone, we know that we are done and we can move on to our next problem, number 2. For number 2, we have g is equal to c plus x, semicolon, 4c. So again, first thing we do is we are going to draw that line down our equal sign to separate our equation into 2 halves. And we are going to circle the variable that we want to solve for, in this case, the c. So what are we doing to that c? We are adding this x. So to undo the addition of x, we are going to subtract x once on each side of the equal sign. G and x are not like terms, so we are going to go ahead and just write them right next to each other. Bring down that c because we did not add or subtract anything from it. And then positive x minus x, just like with numbers, those cancel because they go to 0. And we know we are done when our variable that we want to solve for is alone on the 1/2 of the equal sign. Since that c is alone, we know we are done. Number 3. Scoot it up again. Number 3. We have xc equals g for x. Again, first thing, draw that line down our equal sign, and we go ahead and circle the variable we want to solve for, in this case x, and we look what we are doing to it. Just like when we have a number right next to a variable like 2x, we know that there is some hidden multiplication there. And the same thing applies when we have 2 variables right next to each other. We are doing some hidden multiplication here. So since there is multiplication, the way we get rid of that is by dividing once on each side by that c. Just like with numbers, multiply by c, divide by c, those are going to cancel because they go to 1, leaving us with just that x. And then g and c are not like terms, so we are just going to copy that down, write them on top of each other this time. And we know that we are done because the variable we wanted, that x, is alone on half of the equal sign. Number 4, and the last one on page 41, we have u is equal to k over a for k. So again, line down our equal sign and then circle the variable we want, in this case, this k. Now, division is something we have to keep our eyes sharp for, okay? We always have to get rid of the addition first, no matter what kind of junk is in there, especially if there are several things on the numerator and just one thing in the denominator. We have to get rid of that denominator before we can mess up in the numerator. So we're going to go ahead and we are going to multiply by a once on each side of the equal sign. Now we have some multiplication here. We can either keep that multiplication dot in between them, or we can just write them right next to each other like it was in number 3. I'm going to write them right next to each other. And then just like with numbers, multiply by a, divide by a, those are going to cancel because they go to 1, leaving us with just that k. We know that we are done because that k is alone by itself in that equal sign. All right, let's go ahead and move over to page 42. Take a look at some harder ones. So on page 42, number 5, again, we're only doing 9 of these, is A times M equals N plus P. And we're going to solve for A. So the first thing I'm going to look at is, do we have any like terms on either side of the equal sign? I know A and M are not like terms. I know N and P are not like terms. So no, we do not have any like terms on one half of the equal sign. So we are going to go ahead and just circle that variable that we want to solve for, that A, and then take a look, what are we doing to that A? In this case, we are multiplying by that M. So to get rid of that, we are going to divide by M once on each side of the equal sign. Multiply by M, divide by M. Those are going to cancel because they go to 1, leaving us with just that A. And N plus P over M, none of those are like terms. So we are just going to copy that right on down. And since that A is alone on one half of the equal sign, we know that we are done. Number 2. Nope. Number 6. We have U is equal to AK over B. Semicolon 4K. All right, so again, we're going to go ahead and draw a line through the equal sign and then circle the variable we want to solve for, in this case, this A. So this is what I was talking about, that division that we have to keep our eyes sharp for. We have several things in the numerator that we cannot get to until we take care of that denominator. So to get rid of that denominator or that division, we are going to multiply both sides by that B. B times U, we can keep that multiplication dot or just write them right next to each other. I'm going to write them right next to each other. And then multiply by B, divide by B. Those are going to cancel because they go to 1, leaving us with just that numerator, A times K. And our A is not by itself right now, so we have to do one more step. Like I said, we are multiplying this A by the K, and to get rid of the multiplication, we are going to divide both sides by that variable we don't want to solve for, that K. B, U, and K, none of those are like terms, so we're just going to copy this down, BU over K. Then just like with numbers, multiply by K, divide by K, those are going to cancel because they go to 1, leaving us with just that A. And since our A is alone now, we know that we are done. Number 7. We have G is equal to X minus C plus Y for X. All right. So we have more than one step here. We're going to draw a line through our equal sign. We're going to circle the variable we want, that X. And then we're going to take a look. What are we doing to that X? We're doing 2 things. We are subtracting the C and we are adding the Y. We can start with either one of these. It does not matter. Neither of these is division, so it doesn't really matter. I'm going to start by subtracting the Y first. So since it is a positive Y, that is why I'm going to subtract Y once on each side of the equal sign. G and Y, excuse me, those are not like terms. So we are just going to write them right next to each other. Bring down that X, bring down that minus C because we did not add or subtract anything to either of those. Positive Y minus Y, those are going to cancel just like with numbers because they go to 0. And our X is not by itself, so we know that we are not done yet. So to get X by itself, we are going to do the opposite of the minus C, which is to add C once on each side of the equal sign. Now G, Y, and C, none of these are like terms, so we're just going to add that C onto the end of this line here, G minus Y plus C. Bring down our X because we did not add or subtract anything from that. And negative c plus c, those are going to cancel because they go to 0. And since our x is by itself, we are all done. Number 4. Dang it, number 8. I have them numbered differently on my reference sheet. So we have z equals b plus m over a. Okay, semicolon for a. So I know that we talked about wanting to get rid of that division first. And it's always my first instinct to be like, multiply by that a, get rid of that division. However, if we were to multiply by a, we're not just multiplying the m over a times a. We're also going to be multiplying that b times the a. And then we have to get into factoring to go ahead and solve that. So we are going to take some advice from previous problems that we've done and go backwards through PEMDAS. Get rid of that addition and subtraction first. Okay? So since this b is positive, forgot to circle my a. Since that b is positive, to get rid of a positive variable, we are going to subtract that b once on each side of the equal sign. So we have that z and minus b because they were not like terms. Positive b minus b, those are going to cancel because they go to 0, leaving us with just that fraction m over a. Now what we have to do is get rid of that division. And to get rid of that division, we are going to multiply by a once on each side. But be careful on this left side because the a is not just being multiplied by the z. The a is not just being multiplied by the negative b. The a is being multiplied by the whole thing, z minus b. So we're going to close that in with parentheses. Okay? So since none of these are like terms, we're just going to copy this down. A times z minus b equals, and then multiply by a, divide by a. Those are going to cancel because they go to 1, leaving us with just that m. But wait, we wanted to solve for a, but we accidentally got m by itself. So we have even more steps to go ahead and do to get that a by itself. So again, what are we doing to that a? We are multiplying a by this huge big piece, z minus b. So to get rid of that multiplication, we are going to divide by that huge chunk, z minus b. Multiply by z minus b, divide by z minus b. That whole chunk is going to cancel, leaving us with just that a that we wanted. Okay? And then m, z, and b, none of those are like terms, so we are just going to go ahead and copy this down, z minus b. So since that a is by itself, we know that we are done. Now let's do our 5th and final problem of today, kiddos. This one is mean and evil, so let's go ahead and do our best. Number 5. We have u is equal to 3b minus 2a plus 2 for a. So again, we're going to go ahead and draw a line going down from the equal sign and then circle the variable that we want to solve for. In this case, this a. So we can start anywhere. We could start by subtracting the 3b because it's positive. We could start by subtracting the 2 because it's positive. We could even start by adding the 2a on each side. It does not matter what we start with. I think I'm going to start with just taking care of this 3b once on each side. So like I said, since that is positive, we are going to subtract the 3b once on each side of the equal sign. Since u and 3b are not like terms, we're just going to write them in line with each other, right next to each other. Positive 3b minus 3b, those are going to cancel because they go to 0, leaving us with that negative 2 times a plus the 2 because we did not add or subtract anything from that. And then I think I'm going to go ahead and subtract that 2 once on each side. Since none of these are like terms, I know that 3 looks tempting, but that 3 has that b attached to it. So we cannot take negative 3b minus 2 and get negative 5b. No, because that 2 does not have a b, that negative 3 does, so we cannot. So it just gets added to the end of this conga line. Negative 2a, we just bring that down because we did not add or subtract anything from that. Positive 2 minus 2, those are going to cancel because they go to 0. And then finally, we want to go ahead and divide by this negative 2a because we are multiplying by negative 2 once on each side. So I know that this looks scary. So actually, let's come back to it. Let's look at just this side. Multiply by negative 2, divide by negative 2. Those cancel because they go to 1, leaving us with just that a. Oh, wow, how nice. On the other side, this is all gross. This fraction is all gross. But there is something we can reduce by. And that thing that we can reduce by is a negative. So we are going to change the sign of everything in the numerator and everything in the denominator. Okay? So even though that is nasty and gross, that is our most simplified answer. If you guys have any questions, go ahead and send me an email, kiddos. I will see you tomorrow.